Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, we'll be focusing on a fourth question where I'm tackling rates of reactions. Please do expect a total number of 11 questions, and all of these questions are extracted from past exam question papers. Please do note that, guys, knowing how to tackle exam-like questions will give you an edge whenever you write your exams. So please, guys, do share the video to your peers so that they may have the same edge as you. Okay, we are told that a group of learners uses the reaction of excess hydrochloric acid. Remember that our hydrochloric acid is excess with zinc to investigate the factors which influence the rate of reaction. The balanced equation reaction is given below. Okay. Since our hydrochloric acid is in excess, it simply means that zinc is our limiting reagent. That means zinc will be completely used up in the reaction. Okay, and then we are told that before I continue reading there, the investigation, guys, is to investigate the factors that influence the rate of reaction. Yeah? And we know that those factors are temperature, concentration, pressure, state of division, or you can say it's surface area, and then the last one is an addition of a catalyst. Are you together? So they want to investigate those factors. And then we are told that they use the same volume. They use the same volume of hydrochloric acid and 1.2 grams of zinc in each of the 5 experiments. Okay, the reaction conditions and temperature readings before and after completion of the reaction in each experiment are summarized in the table below. Okay. Firstly, I can see that experiment 1 took the longest amount of time for it to reach completion. And experiment 3 was the fastest to reach completion. Okay. What else do I know? Obviously, the state of division is not the same because our zinc in other experiment is in granule form and in other experiments is in powder. And obviously, the temperature is not the same because it's not consistent. In experiment 4, the temperature was increased to 35 degrees. And obviously, guys, an increase in temperature will obviously affect the rate of our reaction. Yeah? Okay. Is the reaction between hydrochloric acid and zinc exothermic or endothermic? Give a reason for the answer by referring to the data in the table. Okay. A reaction is said to be endothermic if the change in enthalpy is greater than 0, and a reaction is said to be exothermic if the change in enthalpy is just less than 0. How do we find the enthalpy? We just need to take the temperature after reaction subtracted to the temperature before the reaction started. Are you together? So it's basically the heat of the product minus the heat of the reactants. Are you together? And we can see that, guys, we consistently get a positive number because we'll say 34 minus 20, you'll simply get 14. 35 minus 20, you'll get a positive 15 as well. 36 minus 20, it's a positive 16. 15 minus 35, it's a positive 15. And then 34 minus 20, we still get a positive 14. So our change in enthalpy is greater than 0. That's why our reaction is endothermic. Why? Because delta H is positive for in all of these experiments. Okay, give a reason for the difference in the reaction rate observed for experiments 1 and 2. Experiment 2 will reach completion in 10 seconds, and experiment 1 will only reach completion in 50 seconds. So the rate in experiment 2 is higher than the rate of reaction in experiment Y. And why is that? Because the states of division is not the same. In reaction 2, they have increased the states of division of our zinc, or you can say they have increased the surface area of our zinc. Together, surface area of zinc is increased in reaction 2. In experiment 2 rather. Excuse me about that. Okay, and then the learners compare the results of experiment 1 and 3 to draw a conclusion regarding the effects of concentration on the reaction rate. Oh, the concentration was changed there. Oh, I didn't notice. Okay, give a reason why this is not a fair comparison. For reaction 1 and 3, comparing reaction 1 and 3 will never be a fair comparison. Why? Because we have more than one independent variable. Are you together? Firstly, temperature is not the same. That means temperature, concentration rather, is our independent variable, right? Because for experiment 1, the concentration is just 0.5. And then for experiment 3, the concentration is 0.8. Secondly, the states of division is not the same. In experiment 1, we have our zinc in granule form or in solid state. And then in reaction 3, our zinc is in powdered form. Are you together? So we have more than one independent variable. That's why this will never be a fair experiment. Okay. And then 5.4, we are being asked that how does the rate of the reaction in experiment 5 compare to that in experiment 1? Write down faster than, slower than, or equal to. Experiment 1 took too much time to reach completion as compared to experiment 5. Ne? So the rate of reaction in experiment 5 was faster than that of experiment 1. Are you together? And then I must write down the factor responsible for the difference in the reaction in the rates of reaction, and we must fully explain by referring to the collision theory. The temperature is still the same. The states of division is the same. The concentration is the same. The only thing that I'm thinking of has to be catalyst. Are you together? So there was an addition of a catalyst in experiment 5. Are you together? A catalyst was added. Catalyst was added in experiment 5. Are you together? And obviously, guys, whenever you add a catalyst, I'm lazy to write, but please do write this in point form. Ne? Whenever you add a catalyst will always take a path with a lower activation energy. Are you together? Or you can simply say a catalyst will lower the activation energy of the reaction. And obviously, whenever you lower the activation energy, it simply means that more particles will have an average kinetic energy which is greater than the activation energy. And obviously, if you have that situation, it simply means that now more particles will be correctly orientated and hence will end up having effective collisions, and that's why the rate of reaction will increase. Are you together? Let me say that again. In experiment 5, a catalyst was added. Are you together? And then point number 1, whenever you add a catalyst, you will lower the activation energy. Whenever you lower the activation energy, point number 2, you'll simply say particle will have a kinetic energy which is more particles will have a kinetic energy which is greater than the activation energy. And then third point, more particles will be correctly orientated, and then we'll end up having effective collisions in point number 4. When there are more effective collisions, obviously the rate of reaction will be greater. Excuse me about that. The rate of reaction will be greater. Okay, now they want us to calculate the rate at which hydrochloric acid reacts in experiment 4. We must simply write our thing in moles per second. Okay, in experiment 4, the concentration of our hydrochloric acid is 0.5. Were we given the volume of our of this in this reaction? The volume. Okay, there was no volume. Okay, let's use zinc because we have more information on zinc, né? The initial number of moles for zinc. The number of moles actually for zinc is just the mass of my zinc divided by the relative atomic mass number. You'll find the relative atomic mass number, guys, at the back of your question paper. Together. You'll find zinc over there. The number that is written over there, it's a relative atomic mass number. And that number is equals to 65. The mass of my zinc was just 1.2. So I simply have 1.2 divided by 65. This will give me 0.0185 moles. So the initial number of moles for the zinc is just 0.0185. Né? Okay, since I know that, guys, zinc will be completely used up. Are you together? I want to know how many number of moles of my hydrochloric acid will be used for me to completely use this amount of zinc. Are you together? According to a ratio and proportion, I know that I need 1 mole of zinc to react with 2 moles of hydrochloric acid. Are you together? If zinc is just if now I only use 0.185 moles of my zinc, I want to know how much moles of my hydrochloric acid will I need. I just cross multiply. I'll simply have 0.0185 times 2. This will basically give me 0.037 is equals to x. But remember that x is just the number of moles of my hydrochloric acid that will be used up. Are you together? X represents the number of moles of my HCl that will be used up in experiment 4. So that's basically 0.037 moles. Okay, so now for me to find the rate of reaction, experiment 4 reached completion in 8 seconds. So for me to find the rate of reaction, I just need to say the change in the number of moles of HCl all over the change in time. The number of moles that will be used up for my hydrochloric acid is just 0.037 all over the change in time, that's 8. So I'll just divide the number of moles by 8, and this will give me 4.625 times 10 to the power negative 3. This will be moles per second. Are you together? It's moles per second because I'm dividing the number of moles all over time. That's how, guys, you're supposed to tackle that question over there. So just stay tuned, guys, and wait for more videos. Thank you.